We're looking at Chapter 7 Logarithmic Functions, specifically Chapter 7, Section 7.1, represent data using exponential and logarithmic functions to solve problems. In this lesson, we'll investigate characteristics of logarithmic functions by analyzing their graphs and equations. We'll look at increasing and decreasing logarithmic functions, the number of x-intercepts, y-intercepts. We'll look at domain, range, and end behavior. As before, in both Chapter 5 and Chapter 6, we looked at various functions. In Chapter 5, we looked at a linear function, and a quadratic function, and a cubic function. In Chapter 6, we looked at an exponential. Now in Chapter 7, we're going to look at a log function, which is, there's two representations, a log function or a natural log function. If you recall from Chapter 5, we also looked at various characteristics like the number of x-intercepts, y-intercept, end behavior, domain, range. For linear, quadratic, and cubic, we also looked at the number of turning points. We are now going to look at these characteristics for logarithmic functions. A logarithmic function is a function of the form f of x, which equals a times log x base b, where a cannot equal 0, b is greater than 0, b cannot equal 1, and also the argument x must be greater than 0. In other words, this number right here, the argument, must be greater than 0. In a natural logarithmic function, we have f of x equals a times ln x. And now here, the base is going to be the irrational number b. Or the base will be the rational number e. So in looking at a logarithmic function, so if we look at log x, and when we just, base 10 is the base that's on our calculator. If you look on your calculator, you have a log button. That would be base 10. And in this case, you can see that when we put x equals -1, we get an undefined or an error calculation. And when x equals 0, it's undefined. Yet when x equals 1, we get 0. And of course, then it continues. So the graph goes here. You can see that it does not cross the y-axis. Does not cross the y-axis. Since it's undefined, here it does not cross the y-axis. If we look at 2 times log x base 10, once again, base 10 is the one that's on your calculator. The log button on your calculator is base 10. You can see that when you put x equals 0, you get an undefined, and x equals -1 is undefined. So the function, the log function, is only defined for any numbers greater than 0. For x is greater than 0. And here's the graph. Here's the graph of 5 times log x base 10. Once again, you can see the table. Here you have the function is undefined for x equals -1 and x equals 0. So let's look at a logarithmic function versus an exponential function. In the green here, we have an exponential function. We have y equals 10 to the power of x. So that's an increasing function since 10 is the base, if you recall. Here we have the y-intercept is 1. A log function, if there's a mirror here in the line y equals x, a log function is a reflection of an exponential function with base 10. And of course, log x, and this represents log x base 10. We don't necessarily put the 10 there for the base. You assume that if there's no base that it would be 10. You see that they are reflections of each other. If you look at the graph of y equals ln x, that is a reflection of the exponential function y equals e to the power of x. So log functions and exponential functions are mirror images of each other. Let's have a look at another example. We have here y equals 10 to the power of x. We also have x equals 10 to the power of y. And we're going to see later that that's actually y equals log x. And of course that's base 10, even though we don't need to put the 10 there. And if you look at the table of values, again, this is y equals log x base 10. If you look at the table of values, you can see that the x-coordinate of the exponential is the y-coordinate of the log function. And the x-coordinate of the log function is the y-coordinate of an exponential. So they're just, the x's and the y's are reversed. The same here is the y-intercept for an exponential function, 0 and 1. Here is the x-intercept, 1 and 0. So we're looking at logarithmic functions versus exponential function. We're looking at the characteristics. An exponential function has 0 x-intercepts. Yet a log or natural log function will have 1 x-intercept. The exponential function has 1 y-intercept, whereas the log functions have no y-intercepts. And we can see that since the x values and the y values are switched. We have the end behavior of a logarithmic function will go from quadrant 4 to quadrant 1, or from quadrant 1 to quadrant 4. The same for a natural log function. For an exponential function, there's only one type of behavior, and that's from quadrant 2 to quadrant 1. When looking at the domain and range of a logarithmic function versus exponential, we have the domain of a log function is the same as the range of an exponential function. And we have the range of a log function is the same as the domain of an exponential function. And this makes sense since their coordinates, the x and the y, is switched. So an end behavior, and of course end behavior is a description of a shape of a graph from left to right on a coordinate plane. For a logarithmic function, the end behavior would be quadrant 1 to quadrant 4, as in right here, a decreasing function, or quadrant 4 to quadrant 1. That's the end behavior for a logarithmic function. When we're looking at the domain and range for a log function, we have, for a log function, the domain is x is greater than 0. Sorry, that should be x belongs to a set of real numbers. That is, we can only have values for the x above 0, which seems true which makes sense to us since in our table of values, if we try to define, we use our calculator and try to calculate y equals log 0, we will get an undefined answer. An error will come up on our calculator. If we use y equals log of -1, once again, it's undefined. And so, undefined. And so, we see that the domain has to be greater than 0, since any x value less than or equal to 0 is undefined. We also have y belongs to a set of real numbers. So we can have any values for y. The y-intercept, of course, is when the graph crosses the y-axis, and any logarithmic function of the form f of x equals a times log x base b, or f of x equals a times ln x, they will not have any y-intercepts. Since x cannot equal 0, it will never cross the y-axis. So it will get infinitely close to the y-axis, but it will never ever cross, so we'll never have any y-intercepts. The x-intercepts, where the graph crosses the x-axis, the logarithmic function of the form f of x equals a times log x base b, or f of x equals a times ln x, will have one x-intercept. So let's look at an example. Identify the types of functions. So we have to now, we've talked about a linear function, quadratic, cubic, and exponential, and now a logarithmic function. We have to be able to look at a graph and determine what type of function it is. So for the first, we have an exponential function. It's actually an increasing exponential function. And if you remember, for an increasing exponential function, we have y equals a times b to the power of x over c, or just x. We have b will be greater than 1 in this case, since it's an increasing function. If we look at the graph right here, the next graph, we have a cubic function. This one's cubic. And of course, since it takes the shape of an n, that's where it's an increasing, or the leading coefficient a will be greater than 0. We have no turning points here. If we look at the next function, this will be a logarithmic function. This is a log function. It is a increasing log function, as a will be greater than 0. So when you're looking at a function f of x, a log x base b, this function would have a greater than 0, since the end behavior goes from quadrant 4 to quadrant 1. We have an exponential function here. It's actually a decreasing exponential function. So here we have of an exponential function, we have a times b to the power of x. Of course, in this case, b will be greater than 0, but less than 1, since it is a decreasing function. And the y-intercept would be 4. Here we have a quadratic function. We have a quadratic function. A quadratic function is a function of degree 2. This one, in this case, the leading coefficient will be greater than 0. It's positive, since the graph, the parabola, opens upward. And here we have another log function. Here a must be less than 0. Since it's decreasing, the end behavior is from quadrant 1 to quadrant 4. Don't get confused with the exponential function. Don't be confused with the exponential function, a being the leading coefficient and determining what the behavior will be. B determines if it's a decreasing or an increasing function. So let's have a look at an example. So we're looking at a function of the form f of x equals a times log x base b. We're going to identify the domain, the range, the x-intercepts, the y-intercepts of the function, and even the end behavior. We can determine the end behavior. So here in this case, a equals 15, and b equals, since there is no base, we assume the base is 10. That indicates the base will be 10. So we could calculate it using our calculator. In this case, it is a increasing function. It's an increasing log function. Since 15 is greater than 0. The domain in this case, since it is a log, is x is greater than 0, or x belongs to a set of real numbers. The range is y belongs to a set of real numbers. There is one x-intercept, 1 and 0. And the y-intercept, there are none. Here the end behavior, since a is greater than 0, the end behavior will be quadrant 4 to quadrant 1. So let's have a look at another example. Which function matches each graph below? Provide your reasoning. So first of all, let's determine between an exponential function and a logarithmic function. Here we have a log function. Here's a log function. Here's an increasing exponential function. And here in D we have a exponential function. So for the exponential function, for increasing, remember b must be greater than 1. And we have, in equation I, or 1, we have y equals 5, 2 to the power of x. So that would be an increasing exponential function. The only exponential function is left is a decreasing one. Y equals 2 times 0.1 to the power of x. And of course, since b is between 0 and 1, that gives us a decreasing function. For the log function, we have a decreasing log function. So here, a must be less than 0. And here, a must be greater than 0. This equation must be y equals 6 times log x. And this function here must be y equals -2 ln x. If you wish, you can pause the clip and attempt some of these on your own. I'm going to continue. If I'm looking at f of x equals 3 log x, that is an increasing function since a is greater than 0. That is increasing. It is a log function, so x must be greater than 0, and x belongs to a set of real numbers. And the range will be y belongs to a set of real numbers. The x-intercept, there is one, to be 1 and 0. The y-intercepts, there is none. And the end behavior, since it's increasing, will be quadrant 4 to quadrant 1. The next example will be a decreasing function. Since a is less than 0. This number right here is less than 0. We will have end behavior be from quadrant 1 to quadrant 4. Of course, the domain is the same for all, and the range will be the same for all. There are no y-intercepts, of course, and the x-intercept rather, will be the same. So in summary, a logarithmic function of the form f of x equals a times log x base b, where b must be greater than 0, and b cannot be equal to 1, and a is not equal to 0. And a and b are real numbers. Also, x must be greater than 0. All logarithmic functions of the form a times log x and f of x equals a times ln x have these characteristics. There's one x-intercept. There are 0 y-intercepts. The x-intercept will also be 1 and 0. The end behavior will be from quadrant 4 to quadrant 1 for an increasing function, quadrant 1 to quadrant 4 for a decreasing function. The domain is x such that x is greater than 0, and x belongs to a set of real numbers. And the range will be y such that y belongs to a set of real numbers. Of course, if a is greater than 0, the function increases. That is, it goes from quadrant 4 to quadrant 1. If a is less than 0, the function decreases, quadrant 1 to quadrant 4. Here we have a table that now summarizes all the functions which we've looked at. The log function, now just in this section, exponential function from chapter 6, and the linear, quadratic, and cubic functions from chapter 5.